Good morning. It's like 6 o'clock in the morning. I'm just having my coffee, and I just want to let you know I made a mistake. Yesterday, I tried to use the power supply on a repair, and it's quite impossible. My mistake is not reading the manual before buying, of course, because on the manual is saying how this power supply actually is working. Now, check here on the specification. Let's say voltage, you have 1 volt steps or 10 millivolt steps. Don't get me wrong, the power supply is great, but not for repairs. Yeah, like development, like DIY stuff, yeah, it's perfect. But for me, changing the voltage on 10 millivolts is kind of like unacceptable because proper slow. 1 volt steps, it's way too much. Then with the current on the same way, you cannot use like 1 milliamp steps. It will take you forever. And 100 milliamp steps, it's kind of like a lot. So yeah, it is my fault not reading the manual before buying the power supply. Uh, just to make you understand, like for me, power supply is the most important tool. It's more important than multimeter. And I build up a skill on the power supply. I don't think there is any way around on the repair business because you are dealing with IC. IC or a chip, you can't test it with a multimeter because obviously inside you have a bunch of components and you can't really test it with a multimeter. So, in order to diagnose a chip, all what you can do is just to observe the behavior of that chip. Let's say power supplies, because on our field we are dealing with switching power supplies. Um, a power supply, let's say you have a power supply on a motherboard, and okay, that power supply is behaving strange. Let's say it like that. So you have the power supply there, and you supply some voltage. You see the power supply is taking some current, and you have to decide if that power supply itself is faulty, or something after the power supply is faulty. And that's very simple. With the power supply, you just increase the voltage. Problem is you don't know if you have to increase the voltage slightly or more, but you decide that in the moment you increase the voltage and you observe the current. If you increase the voltage and the current is going down, you know that power supply it is good. And most likely your problem is after the power supply, on the output of the power supply. But if you increase the voltage and the current is going up, you know that's what I call dead current. Yeah, so that current is going on a passive component, and in that moment, you know actually that power supply, that chip, it is faulty. So that's why, for me, the power supply is a very important component. I should read the manual before ordering. Yeah, you're right. And you know why I feel bad? Because this power supply is perfect. I mean, the way how it's built, the stages with the relays, yeah, are so many. It's like it's like the perfect power supply with the bad programming panel. I mean, it's not bad. It's just not fitted for repairs. For anything else, I'm pretty sure this will be perfect. Now there is something more about this power supply. Let me plug the power. And I observed this yesterday when I tried to work with the power supply. I mean, I don't think this. I'm not sure if it's a fault or that's how it's supposed to be. So the button is very sensitive. So they are clicking, click, click, click. Yeah, you can feel the click. You can't hear it. You can feel it. Yeah, but if I try to like move the button, check there. So just by moving, not spinning the button, just moving the button, and the voltage is changing. And I'm not sure if this is supposed to happen. I don't know. Maybe it's too sensitive for DIY and development. It doesn't matter because You set up the voltage, then you press output, and you work with whatever you have to work. But on the repair field, something like that, increasing the voltage with 1 volt by moving the button somehow, like up down, like touching the buttons on the wrong way. This is kind of like unacceptable. But anyway, for anything else, this power supply probably it will be perfect. I'm not gonna send it back. I will list it on eBay. In the worst case scenario, I wish I could modify this, but you can't modify it because you need analog potentiometers, and those clicking things are not potentiometers. And you have a microcontroller with a program, so no, we can't modify. It will be too complicated to modify this one. Now, regarding the computer connection, because we said the power supply didn't have computer connection, that's not a problem. I remember this one. This one has a beautiful program. You can plug by the micro USB and install the software, and easily we can modify. You need ground, you need input and output, and we can add this to the power supply and actually have reading, current and voltage reading on the computer. So that's not a problem. That's not a problem with the power supply. So we are back to the square one. We know power supply. Okay, let me show my other power supply. Yeah. So this is one option we have. My 20 years old power supply. Yeah, this one. So this is it's not 10 amps. I believe it's 15 amps power supply. What I know it's kind of like faulty, like partial faulty. It's going up to 11 amps, if I remember. Let me plug the power. So the power is plugged, and the digits. Okay. Anyway, has a relay. Here, I think the power supply has an issue. So shorting the... Okay, rising the current. Oh, has short circuit protection. Ah, lol. Okay, now I remember. We have to remove the short circuit protection on this one. So we cannot push the current without a resistance. Let me see if the probes, we can simulate a resistance. Let me lower the voltage. Yeah. So check there. We have 8 amps. No, we can't do it. Yeah, the protection came in. So if we are using a wire to simulate like a resistance, so we can push current, then we can push current. Let me raise the voltage. We have 6, 7, and the wire is smoking. Can't believe. Check here. Yeah. So pushing current. Let me see how much current I can push. Yeah, we can't push current anymore. Yeah, like 10 amps. Then protection is kicking in. And the second option is actually getting the old power supply back. Yeah, I did a mistake. The problem is my mistakes cost money. No, I'm not gonna search for more power supply. No, it's it's too expensive for me. So I think we have to learn to be happy with what we have. And if we don't like what we have, we should modify that thing to work the way we want. Yeah, just a short update about the power supply. I mean, you can get used with a solar iron, a different solar iron, different multimeter. But power supply, you diagnose things based on the power supply. You can actually use the power supply as a voltmeter. So if I'm switching the power supply to 0 volts, I can actually check voltages. So if you give me to pick up one tool, it will be the power supply. If it will be to say like, okay, what is the secret? Sonic's secret, the power supply. I mean, the whole diagnose thingy is based on the power supply and based on what I'm seeing with the power supply. So what I want from a power supply is to be stupid, just simple, stupid. So I can observe how the power supply it's reacting. That's why I cannot use like programmable power supplies or something like that with steps. Yeah, I need a continuous analog knob. Great. So I'm gonna stop here. I will let you know what I will decide. Maybe we can speak Sunday on the coffee time about this. But don't do the same mistake as I did. Take your time and read the manual before buying whatever you are buying. Okay? Yeah, have a fantastic day. Bye.